Keisuke Miyako is a great example of the variety of talents and knowledge within 4D, whether it is his knowledge of multiple computer languages that lead to an impressive collection of plugins on his GitHub account, or his knowledgeable replies on the INA. He is not only a resource for 4D, but for the 4D community. Keisuke?
Right. In this small section, I'd like to talk about 3 new features that we plan for V16, but you can start using in V15 R4 if you have subscribed to the continuous delivery program, the R release. So 3 new features. Feature number 1 is a new kind of 4D tag. So you have 4D text, 4D loop, and in V15 we introduced the most powerful tag today, which was 4D eval. Now we have an even more powerful tag coming. So that's feature number 1. Feature number 2 is a new syntax. You see, in the first version, 4D tag were using square brackets. The current syntax is like an HTML comment. And now, in addition to our current syntax, we have a new syntax which will give you more flexibility. And feature number 3 will that be explained in the demo. Demo. So here I have a small database application. There's 2 tables, 1 to n relation, and you can see the data is displayed in this block. Now suppose I wanted to export this data in a spreadsheet. So click on the Excel button, and then click on this launch, and again a spreadsheet. The columns on the blue, with a blue header, they represent records coming from the 1 table. The columns with the red header, these are calculated values based on collection of data, and there's also the total, which is a computation on the computation of records. So here, a nice looking spreadsheet. So how did I create this in 4D? Well, if I go back to the demo application and open the method, you see that there's only really 3 lines of code. The first line, to load a template from the resources folder, then the magic command process for the tags, and then finally another line to export that data as a file and then open it in Excel. So that's all 3 lines. Yet the result was quite impressive. It was a real spreadsheet, so with several sheets. And also, if we go back to the first sheet and take a zoom into the actual cell value, you see that some cells are actually using macros to reference other cells to show a dynamically computed value. Just to illustrate, if I change values in the ID field, you can see that the B column is following that change. And also, if we change the value on one of the hidden sheets, then also go back to the first sheet, and the value which was 58 is now 60. So you can see that the data integrity is kept. It's a real spreadsheet used to show relational data. Now, the real interesting part is the actual template. So I'm going to open the template using a text editor, and here, this is the template. This is our first new feature. It's a new kind of tag, 4D code tag. It's similar to 4D eval, but unlike 4D eval, where you can just write 1 line of code, 4D code, this new tag, allows you to put native 4D code across multiple lines. See? So you can just take your existing method, copy a block of code, and just paste it inside 4D code tags, and there it works inside a template. So this is our first new feature available in V15 R4. Very useful. Okay, there are some instances of existing tags, 4D text. There's another one there, 4D text. And also, you see 4D text again, but this time using slightly different syntax. This is our second new feature, which is the $ syntax. You see, instead of using HTML comments, you precede the tag with a $sign, and then pass any formulas you need to, expressions you need to evaluate inside brackets. So this gives you the ability to put 4D tags inside, for example, an XML attribute where you are not allowed really to use the greater than, less than sign. So it gives you more flexibility in how you would use or where you would use your 4D tags. So this is our second new feature, the $syntax. See? Again, very useful. You can have as many instances of 4D code tags as you like. You can query a database, you can use arrays, pointers, objects. Basically, you can do anything you would do in your 4D method. And perhaps you've noticed that each command has a suffix, a colon, C47, for example, for all records. This is the command number. This is what we call a future-proof way of writing 4D code in plain text. It's optional, so you don't have to do it, but it allows you to, for example, embed 4D code using the French command name, and it will not break regardless of the system environment that you actually deploy your application. It keeps your code intact, and for example, if the command name changes in future versions, again, your code continues to work. And what's nice with V16R4 is that the existing command method get code has been extended to accept a new star asterisk parameter, which will convert your code with the suffix, so you don't have to do it manually. It's automatically been done with 4D, and you just take that code, paste it in your template, and it will work. So this was about using 4D tags to create a spreadsheet. So unless it was unclear, I launched Excel and created my spreadsheet without the data, with the formats and the sheets, and then saved it as XML, and then opened it with the text editor and just put my code to reference the data so that the data is embedded in the final result. So that's one example of how you could use 4D tags to create data-driven dynamic documents. In my second part of the demo, I'd like to show another example, which is to do with graphs. You see, there are many good JavaScript graph libraries for the web that, for the most part, accept data in JSON format. So you supply your data in JSON, and the library just does an order for it, and you get a graph. Now, JSON is a text format, so again, you can take advantage of 4D tags to generate JSON very efficiently. And here's the example. And this time I'm going to launch a browser, and when I click and access a particular URL, the URL data1, I get all my data in JSON format. It's an array of objects. If you take a closer look at the URL, I can actually add a parameter. For example, in here, I'm typing year equals 2016, and then the selection has been filtered to only data that meets the condition. And here's the template used behind the scenes. Again, I'm using 4D code. Take a look at line number 8. You see where to get variables. So here I'm checking the parameters. If there's extra string appended to the URL, if I find the variable year, then I'll take that and line 13, query by formula to filter the selection. Otherwise, I'll just go to line 15, all records, display all records. Then scroll down, we see an instance of 4D loop, so that works on the selection to generate the JSON, and finally another block of 4D code to make sure that the browser doesn't cache the result and access the database every time. Now, in the second line, you see a line commented out. It says C157. You see, if you use the suffix, actually the command name that precedes the colon is ignored, which is why it will work with the English name, old name, French name, whatever. You can even just pass nothing and still it will work. Now, C157 means command number 157. So the question is, which command is it? Uncomment the line, and then the browser, reload the page, and there you go. 157 is the command trace. So this is a third new feature, which is that you can debug your code embedded inside your template. So that's a new feature. This is going to save, I'm sure this is going to save a lot of your development time. Already know. Now that we've got the JSON, it's just easy. You just connect your JavaScript page to your URL, and then you get a nice looking graph. So in this example, I'm using the d3.js library that's very popular, and it's a very sophisticated result. Now, different charting libraries expect, well, they all expect data in JSON, but data in a different kind of JSON. So let's say I wanted to add a different library. So again, I go back and then create another template. So instead of data 1, I have data 2. And then if I change the URL to data 2, then obviously I get a different result. And now this URL is designed to take the parameter name equals apples, and then I get all the data related to my apples. Now I have a new endpoint, so it's just a matter of adding a new page, which will access the new URL, and then I get a different result. So the important point here is that it's all done live. You see, to add a new page, all I did was just add a new URL using 4D tags in a different way, and then just change the URL and got a different result. So it's very efficient, very productive. Now this example is using another library called Chartlist.js. It's quite new. It's very easy to use. It's optimized for graphs. You can implement lazy loading. So you scroll down and then the graph is gone, so it gives more efficiency, especially on the mobile. And this library, what's good about this library is that it is responsive, so it adapts to the screen size. It's large, it's large, small, small. Okay. So that's the demo. 4D tags. What's the point? Well, it allows you to take full advantage of existing code. You see, whenever you have to work with XML or HTML, you can just process 4D tags. It allows you to take a quick shortcut to your end result. By taking advantage of the various 4D tags at your disposal, you can quickly create a template. And once you have a template, then you can use the same method to generate all sorts of different documents. In summary, the new 4D code tag allows you to take a block of 4D code and reuse it in a template. The dollar syntax gives you more flexibility with where you use the 4D tags. And now you can actually trace and debug your 4D code. So that's all from me. Back to you.